On July 19th, as Spain and Argentina walked out onto the pitch in New Jersey for the World Cup final, European weather monitors were actively tracking whether smoke from wildfires burning more than 1,000 miles away in central Canada might drift over the stadium before kickoff. That is not a detail from a disaster film. It is a real forecasting concern that Europe's own flagged directly in its public updates that week, and it captures something genuinely unusual about this year's Canadian wildfire season. The smoke pouring out of Ontario, Quebec, and the Northwest Territories this July has not stayed a North American problem. Satellites have tracked it crossing the entire Atlantic Ocean toward Europe, drifting north into the Arctic, and settling thick enough over the Great Lakes and Northeast United States to make cities like Duluth, Minnesota, register air pollution levels more than 3 times the threshold. Considered hazardous, worse for a stretch of days than anywhere else in the country. This is the story of how a wildfire season burning, entirely within Canada's borders, became a genuinely global weather story, tracked by scientists on 2 continents, why NASA's satellites can now do something they could not do a year ago to study it, and what that tells us about how often this kind of continent-spanning smoke event is likely to happen again. No exaggeration, just what NASA, Copernicus, and the atmospheric scientists tracking this exact smoke plume are actually reporting. Drop a comment and tell me if the sky where you live has turned hazy, orange, or simply dimmer than normal at any point this July. Because if it has, there's a real chance you were looking at smoke that started as a fire hundreds or even thousands of miles away in Canada. I read every one of these. If you want grounded science and weather coverage instead of recycled panic, subscribe. It is free das, and a like helps this reach people before the next plume reaches their own sky. Let us go for 5,000 likes on this one. Now let us get into it. To understand how smoke from a fire in northern Ontario ends up affecting air quality forecasts for a soccer match in New Jersey or a sunset in Lisbon, you first need to understand what actually happens to smoke once it leaves the fire itself. Intense wildfires push enormous columns of hot particle an air high into the atmosphere, sometimes tens of thousands of feet up, well above where ordinary weather forms. Once that smoke reaches those higher altitudes, it stops. Behaving like local haze, and starts riding the same fast-moving upper-level winds that steer entire weather systems around the globe, capable of carrying fine particulate matter, black carbon, and a specific kind of organic carbon called brown carbon, thousands of miles from its source before it ever settles back toward the surface, occasionally staying aloft long enough to circle a meaningful portion of the hemisphere before finally dispersing. This year's Canadian wildfire season began slowly, but conditions shifted abruptly in mid-July when the same heat dome that had already baked much of the eastern United States extended its reach into Ontario, priming the landscape. There, with exactly the hot, dry conditions that allowed dozens of separate fires to ignite and grow explosively within days of each other. By July 15th, more than 800 individual wildfires were burning across Canada simultaneously, and intensity researchers have directly compared to the country's severe 2014 and 2023 fire seasons, with the Northwest Territories specifically seeing persistent large-scale burning since late June that satellite-based emissions tracking placed well above the 20-year average for that region. The scale of what that smoke did to air quality across North America over the following week was genuinely extreme. Thick haze enveloped the skies above Toronto, Boston, and New York City, with several of these cities registering among the most polluted air anywhere in the world on certain days. Duluth, Minnesota, a city that has historically marketed itself as a climate haven precisely because of its clean air and cool summers, recorded a 24-hour air quality index for fine particle pollution of 934 on July 16th, more than 3 times the threshold at which air is officially classified as hazardous, a genuinely remarkable reading for a city that size. The Copernicus Atmosphere Monitoring Service, tracking the same event from its side of the Atlantic, confirmed the smoke was degrading air quality across a long corridor stretching from the densely populated Great Lakes region all the way to the U.S. East Coast, with millions of people exposed to hazardous air quality levels, in some cases more than double the threshold considered dangerous. Here's where this stops being a familiar North American smoke story and becomes something scientists are specifically describing as a global event. Satellite data from the European Space Agency's Sentinel-5P instrument tracked the smoke plume moving eastward across Canada and the United States over 4 days in mid-July before curving out over the open Atlantic, carried by prevailing winds far from where it originated. Separately, Copernicus confirmed that large plumes of the same smoke reached north into the Arctic, a detail that matters beyond simple air quality, since soot particles that settle onto Arctic snow and ice darken those bright surfaces, causing them to absorb more sunlight and melt somewhat faster than they otherwise would, a secondary climate effect entirely separate from the smoke's immediate impact on the people breathing it. This is not the first time Canadian wildfire smoke has crossed the Atlantic. Similar transatlantic plumes reached Portugal, Spain, Greece, and the wider Mediterranean during Canada's record-breaking 2023 fire season, and again in the spring of 2025, when an initial high-altitude plume crossed into the eastern Mediterranean in mid-May before a larger, lower plume settled over northwestern Europe just weeks later, meaning 2026's version is not an isolated fluke, but the continuation of a pattern that has now repeated across multiple consecutive fire seasons, each one tracked and documented in detail by the same European monitoring network. There's a genuinely new scientific tool behind how precisely researchers have been able to track this specific event, and it is worth understanding why that matters. NASA's Goddard Earth Observing System model gained a significant new capability in February of this year, allowing it to separate brown carbon, the specific organic carbon signature produced by wildland fires, from black carbon produced by ordinary human sources like vehicle exhaust and industrial combustion, sources that had previously blended together in earlier versions of the model and made it harder to isolate exactly how much of any given haze event traced directly back to wildfire smoke specifically. That upgraded capability let NASA produce detailed source-specific visualizations tracking this July's smoke plume day by day as it crossed the continent, giving scientists a considerably sharper picture of exactly how far, how fast, and how intensely wildfire-specific pollution was actually traveling, rather than relying on broader estimates that mixed multiple pollution sources together. The public health stakes behind tracking this smoke as precisely as possible are considerable, and researchers studying the issue have been explicit about why. Jane Burston, chief executive of the Clean Air Fund, told Euronews this month that wildfire smoke carries fine particles small enough to pass directly through the lungs into the bloodstream, capable of triggering asthma attacks in the short term and, with repeated exposure over years, contributing to lung cancer, heart attacks, strokes, and even dementia health. Consequences that accumulate quietly over an entire career of smoky summers rather than announcing themselves after any single bad air day. Burston pointed specifically to Canada's catastrophic 2023 wildfire season, historically the country's worst on record by area burned, as a stark illustration of the stakes involved, citing an estimate that toxins and pollution from that single season's smoke may have contributed to as many as 2,000 deaths, a figure drawn from broader mortality, modeling around fine particulate exposure rather than a direct confirmed body count, but one that underscores just how seriously public health researchers are now treating wildfire smoke as a genuine cross-border health threat rather than a temporary visual nuisance. It is worth being precise about what can and cannot be said with full confidence here, because both the health estimates and the exact path any future smoke plume will take carry real uncertainty. Mortality estimates tied to fine particulate pollution are built from population-level statistical modeling, comparing exposure levels against known health outcomes, not a tally of individually confirmed deaths, which means these figures represent researchers' best current estimate rather than an exact count. And different methodologies can produce meaningfully different totals. Similarly, while satellite tracking can confirm precisely where a smoke plume has already traveled, forecasting exactly how much of any future plume will reach ground level in a specific city, as opposed to remaining high enough in the atmosphere to simply tint a sunset without materially affecting air quality, remains a genuinely difficult forecasting challenge, which is part of why agencies like Copernicus continue actively monitoring these events in near real time rather than issuing single static forecasts days in advance. Even the World Cup-related monitoring earlier this month illustrates that same uncertainty, since forecasters were watching the possibility of smoke affecting the New Jersey final closely, without being able to guarantee days ahead of time exactly how much, if any, would actually reach ground level by kickoff. There is a broader pattern worth understanding here, because this year's event did not emerge in isolation. Canada experienced a relatively calm start to its 2026 fire season before conditions shifted abruptly in July, but that abrupt shift itself fits a trend researchers have been documenting across recent years, intensifying wildfire seasons, compounding with a warming climate that is making the specific combination of heat and dryness capable of igniting explosive fire growth measurably more common. The same broad atmospheric pattern responsible for this year's smoke, a persistent heat dome extending its reach into Canadian territory, is functionally the same mechanism that has driven Europe's own destructive wildfire season this summer, meaning smoke crossing the Atlantic in either direction this year reflects two continents, experiencing closely related consequences of the same broader atmospheric setup rather than two entirely separate weather stories that happen to be occurring at the same time. So what does all of this actually mean for you, regardless of which side of the Atlantic you live on? If If you are anywhere across the Great Lakes, Midwest, or Northeast United States, or in eastern Canada directly, keep checking real-time air quality readings during any period when regional wildfire activity is elevated, since smoke can settle to ground level with relatively little visual warning, even when the sky does not look dramatically orange. And pay particular attention if you are older, have young children, or manage an existing heart or lung condition, since fine particulate exposure affects those groups disproportionately. If you live in Europe, understand that a hazier than usual sky or unusually vivid sunset during the summer months may genuinely be linked to smoke that crossed an entire ocean to reach you, even if regional air quality readings remain in a technically safe range, because most of that smoke stays high in the atmosphere rather than settling to ground level. In both cases, treating wildfire smoke as a recurring, expected feature of summer months going forward rather than a rare one-off event is now the more realistic way to plan around it, given how consistently this exact cross-continental pattern has now repeated across the past several fire seasons. The honest, grounded summary is this. Wildfire smoke from more than 800 fires burning across Canada in July 2026 pushed air quality to hazardous levels across major cities from Toronto to New York, with Duluth, Minnesota recording pollution levels more than 3 times the hazardous threshold on its worst day. Satellite tracking confirmed that same smoke crossed the entire Atlantic Ocean and drifted north into the Arctic, continuing a pattern first documented at this scale during Canada's record 2023 fire season and repeated again in 2025, making this the 3rd consecutive year this specific transatlantic smoke transport has occurred. NASA's newly upgraded modeling capability allowed scientists to track this specific plume with a level of precision not available even a year earlier, distinguishing wildfire-specific brown carbon from ordinary urban pollution for the first time, while public health researchers continue warning that the cumulative toll of repeated wildfire smoke exposure, estimated in the tens of thousands of deaths during Canada's worst prior season alone, makes this a genuine cross-border public health issue rather than a temporary seasonal inconvenience. We are going to keep tracking this exact story the way we tracked it today, straight from NASA, Copernicus, and the atmospheric scientists monitoring this smoke plume in real time, not recycled headlines. Subscribe so you do not miss it the next time a plume like this one crosses an ocean, because based on how consistently this is repeated across the last several fire seasons, it is very likely to happen again. And leave that comment below. Tell me if you had any idea wildfire smoke could realistically travel far enough to affect weather forecasts on another continent entirely, because that scale is exactly the part of this story most people never hear about, and it is worth understanding now before the next major plume forms somewhere else on the map. Because behind every one of these satellite maps is a family in Duluth who moved there specifically for clean summer air, now checking an app before letting their kids play outside, a fire crew in northern Ontario working a blaze that will eventually darken a sunset thousands of miles away in a country they will likely never visit, and a stadium full of soccer fans in New Jersey who had no idea, as they watched a World Cup final, that a wildfire on another part of the continent was quietly part of that night's weather forecast. Tracked in real time by scientists most of them will never know existed. 5,000 likes on this one. Let us go. See you in the next one.